Alright, this is part 3 of our lesson on solving systems of polynomials. If you watch the other 2 parts, you should already have a pretty good idea of how to do these problems. So, put your pencil down is what I'm saying. Try to do this problem by yourself. If you already know that you're stuck, then that's fine. I'll watch the video, but don't copy off of me while you're watching the video. Watch and see how I do it, and then pause the video and go back and try to do the problem by yourself. That's when the real learning happens. Alright? Otherwise you'll think you know what you're doing, but then the test comes and oh, turns out you didn't actually know what you were doing. So put your pencil down. Bottom line. Okay, in problem number 5, this top equation is quadratic. But there's a special name for it. Okay, quadratic function graphs are called parabolas. So we have a parabola and a line. Parabola and a line. So in general, we're talking about something like this. Okay, you got your parabola doing something like that, and then you got your line doing something like that. Okay, so we're expecting up to 2 solutions, up to 2. Alright, well, we won't know until we actually do it, so here we go. Okay, I'm definitely going to use substitution once again. So I have y equals 6x squared for my first equation, and then I have 7x plus y is equal to 3 for my other equation. So y is already by itself, so that's why I'm just going to go ahead and use this and substitute this in for y in the other equation. So this equation will then become 7x plus 6x squared is equal to 3. Now I see I've got a quadratic term, a linear term, a constant term. This is the type when we get 0 on one side, we try to factor or use the quadratic formula. So first of all, this is all out of order, so I might just sort of switch these around. I'm not subtracting 6 from both sides or anything like that. I'm just using the commutative property of addition to write this how I'm more comfortable. So this would be x squared plus 7x. I just simply reversed them. Okay, equals 3. Now I need to get 0 over here, so I am going to subtract 3 from both sides, like so. Okay, there are no like terms to put it with, so that's just going to make x squared plus 7x minus 3 equals 0. Now it would be lovely if this is factorable and I didn't have to mess with the quadratic formula. Some of you maybe just love the quadratic formula. Whoa, crazy talk. And you would prefer just to use it straight away. You knock yourself out if that's your thing. I kind of enjoy factoring because it's like a little puzzle that I can solve. When I look at that 6, I'm thinking, is this going to be 2 times 3? Or is it going to be 1 times 6? I always start off with the 2 times 3. Always. Alright, now I look at this 3, and I know this can only be 3 times 1. Alright, it's the only way. Now I'm not going to put the 3 here, though, because that would make a GCF. If there's no GCF in the original problem, there shouldn't be a common factor in the parentheses either. So, why does it keep doing that? So I'm going to save my time by only doing 1. Okay, I just said I wasn't going to do that, and it's going to do that crazy thing again. So annoying. So I'm going to put the 3 here and the 1 here. Okay, inner plus outer equals middle, right? Inner, I've got 9x. Outer, I have 2x. I'm trying to get a middle of positive 7. If I have a positive 9 and a negative 2, that'll make positive 7 middle. For the positive 9, I need this to be positive. For the negative 2, I need this to be negative. Am I getting the negative 3? Yes. A positive times a negative is a negative. So I have factored it properly. Okay, no problem. So let's go ahead and, why does it keep doing it? Alright, maybe if at least if I touch this, it'll go back to there next time. Talking to myself, people. It's 2:20 a.m. Just in case you're wondering, just how crazy is this guy? Yeah, he's making a video at 2:20 a.m. on a Sunday. That's how crazy he is. Alright. I'm going to set these factors equal to 0 now. So if I do that, I'm going to have 2x plus 3 equals 0, and I'm going to have 3x minus 1 equals 0. So subtracting 3 from both sides, that'll be 2x equals negative 3. Okay. So dividing by 2 on both sides, that gives me x equals negative 3 over 2. So that is one x value. Alright, put that in your back pocket. I'm going to add 1 to both sides here, so that'll give me 3x equals 1. Okay, then I'm going to divide both sides by 3. And so that's going to give me x equals 1/3. That's another x value. Fine, alright, these are fractions and all, and don't use decimals, please, use fractions. But I still need the y values to go with them. So negative 3 over 2 and 1/3. So let's make that t-chart. Alright, x, y. Okay, what did I say? Negative 3 over 2 and 1/3. Let me just double check. Negative 3 over 2 and 1/3. Great. Now I need the y values that go with them. Okay, well, as you can see, y equals 6x squared. Alright, just copied it right from there. So that means this y value is going to equal 6 times negative 3 over 2 squared. So here's 6 times negative 3 over 2 squared. Alright, that's 27 halves. Okay, so 27 halves. And now this one is going to be 6 times 1/3 squared. Okay, so here's 6 times 1/3 squared. And that's 2/3. Okay, so there we have our two solutions. Why not? I'm going to use this green color. So that's going to give us, okay, that's way too big. I'm just going to use it, whatever. So I've got negative 3 over 2 comma 27 over 2. That's 1 point. And I've got 1/3 comma 2/3. Alright, those are the two solutions, unless I made some sort of a horrible mistake. Okay, we were expecting two solutions, boom boom, and we got two solutions. Now let's check our answers using Wolfram Alpha and just get a picture of how it actually looked. Alright, first equation was y equals 6x, whoa, squared. Got to use that caret. And then we type and then the other one was 7x plus y equals 3. So 7x plus y equals 3. Alright, just hit enter and let's see what we got. Wolfram is thinking. Alright, is it done? Okay, this is what we've got. So you see our parabola and our line, and you can see the points of intersection, and let's just scroll down and see the actual solutions. Okay, see if they agree. Negative 3 over 2, 27 halves, 1/3, 2/3. Alright, so we nailed it. Alright, and it went down just like we thought, except for the line was going with a negative slope instead of a positive slope. But you know, it's our initial guess was pretty close to being just exactly how it went down. Alright, one more problem. And again, please, if you have a pencil in your hand, you are messing up right now. Alright, put your pencil down, put your pen down. Do not be foolish. You will not learn by copying off of me. So what do we got here? Okay, do the problem yourself. In fact, you just watched me do this whole problem. So pause the video. You should be able to do number 6 by yourself now. So pause it. Yeah, let's pretend like you did that. So the top equation is quadratic. So we know this is a parabola. The lower equation is linear. So this is a line. So that means we're dealing with the same type of thing as before. Alright, a parabola and a line. Okay, so we're looking for up to 2 solutions. So let's see how it goes. Substitution, my friends. Substitution has really been working for us today. So let's just keep it going for one more problem. So I've got y equals, this is how I want to do it. Yeah, y equals 2x squared plus x. Okay, that's our first equation. And then we have 2x plus y equals 20. So y equals this. We already have y by itself. So let's go ahead and take this and substitute it here in the other equation. So that'll give me 2x. Okay, and just to be clear, it's going right here. So plus 2x squared plus x. Alright, that's the substitution that just happened. And equals 20. Alright, I do have some like terms here, don't you know? Alright, the 2x and the x together make 3x. Yeah, that's right. So as I recopy, then start with 2x squared. So I have 2x squared, and then my like terms here. So I've got plus 3x equals 20. Now I need to get 0 over here so I can factor and stuff. So, you know, watch out for that. So I'm going to subtract 20 from both sides. So these will cancel. So now I have 2x squared plus 3x minus 20 equals 0. Okay, I don't see any common factors or anything. So I'm just going to go ahead and try to factor this as a binomial times a binomial. Alright, I have a good feeling that this is going to factor. Okay, 2x squared can only factor as 2x times x. As I look at that 20, you know, there's more than one possibility for the 20. Alright, the 20 could either be 4 times 5, or it could be 2 times 10, or it could be 1 times 20. I'm going to start with the 4 times 5, but I am not going to waste my time putting the 4 here, because that would cause a GCF. If there's no GCF in the original problem, there should be no GCF inside the parentheses. Okay, so don't waste your time putting the 4 there. Instead, go 5, 4, like that. Now let's check our inner, outer, middle situation. Inner, we have 5x. Outer, we have 8x, because we multiply. We're trying to get a positive 3 out of it, positive 3x. That will happen if I have a negative 5 and a positive 8. So this will give me my negative 5x, and this will give me my positive 8. Does that give me a negative 20? Yes, it does. A negative times a positive is a negative. So we have, in fact, factored it correctly, so that's genius. But now we have to take these factors and set them equal to 0. Okay, so we are doing 2x minus 5 equals 0, and x plus 4 equals 0. Adding 5 to both sides gives us 2x equals 5. Okay, dividing by 2, alright, is just going to give us 5 over 2. So I have x equals 5 over 2. So that's one x value for me. Now over here, of course, I'm just going to subtract 4 from both sides. So that's going to give me x equals negative 4. Okay, so I have two x values, 5 over 2 and negative 4. Alright, let's go make our t-chart. Alright, our xy chart. Okay, so we had negative 4 and we had 5 over 2. Now, this is all squared and whatnot. I could use this. You have a choice, all right? To get these y values, you can use either one of the original equations. Okay, so I could do 2 times negative 4 squared plus negative 4. All right, there's nothing wrong with that. Or I could use the second equation. So let me just show you real quick off to the side if I wanted to use the second equation. So I've got 2x plus y equals 20. How easy would it be just to subtract 2x from both sides? So that just gives me y equals negative 2x plus 20. Okay, so you might want to use this equation. It's a little simpler. You might want to use your negative 2x plus 20. So that's what I would do. It really doesn't matter as long as you're careful, but I would probably go ahead and do the negative 2x plus 20 option from the second equation. Anyway, so that's going to give me negative 2 times negative 4 plus 20, which, obviously we can do in our heads, and we will. So negative 2 times negative 4 is positive 8, so this is just 8 plus 20. So that's 28. Okay. Now if we do the same thing here, that's going to be negative 2 times 5 over 2 plus 20. Now I can do this in my head because I'm going to go, oh, these 2's are going to cancel, and that'll just be negative 5 plus 20, and that'll be 15. Okay, alright, I know you're impressed by that, but many of you are like, what did you, what? And if that's what you sounded like, okay, with my dead accurate impersonation of how you sounded right then the TI-30 XS multiview is for you. So negative 2 times 5 over 2 plus 20. Alright, negative 2 times 5 over 2, okay, plus 20. And what do you know? 15, just like I said. Alright, so there we have our two solutions. So I have negative 4 comma 28, and I have 5 over 2 comma 15. Okay, put a box around that. It's brilliant. So we were expecting, what were we expecting? We were expecting two solutions. up to 2 solutions. We have 2. Let's one more time, let's take a glance at the electronic version, check our answers on wolframalpha.com. Alright, the first equation is y equals 2x squared plus x. So y equals 2x squared plus x. And, alright, our second equation is 2x plus y equals 20. Alright, so 2x plus y equals 20. Hit enter, and let's see what we've got. Alright, still thinking, freezing up a little bit. Now remember, back from the beginning, we knew we had a parabola and a line. We're looking for this type of thing. Now Wolfram Alpha is coming up with this. So just like we thought, we have our parabola and our line, okay, with our 2 intersection points. So it's happening just like we suspected. And let's just double check the actual answers. So -4, 28, and 5/2, 15. Okay, that's exactly what we got. Alright guys, that is it for this lesson. I hope it was helpful to you. Alright, let's take one more look at that lovely graph from Wolfram Alpha. So I hope you're learning how to use Wolfram Alpha as well to check your answers and such. Alright, it will help you get some good connections as you go through your math journey. I will see you on the next video, guys. Good night.